Today we are now discussing about the linear programming problem, chapter 3.
Start.
Before going to linear programming problem, we have to know about the linear programming and its application. It is an important optimization, that is maximization or minimization technique used in decision making in business and everyday life for obtaining the maximum or minimum value as required of a linear expression to satisfy certain number of given linear restrictions. And the second part, we have to find out the maximum profit or minimum cost or minimum use of resources, etc. Also, it is history or commerce, management, science, engineering, etc. Before going to linear programming problem, you have to know about some definitions. What is optimal value, maximum or minimum value of a linear function or expression? You know about the linear function. Suppose z equals to f of x comma y. That is a linear function. That is an implicit function because the left side is z and the right side is x comma y, and there are two variables. Z is a dependent variable and x y independent variable, but it is an implicit function. But it is in linear programming problem, it can be taken as a linear function or expression. What is the objective function? The function which is to be optimized or maximized or minimized. Linear function, suppose z equals to x plus ax plus by, where a and b are constant, which is to be maximized or minimized, is called the linear objective function. And x and y are called decision variables. System of linear inequality of x and y with non-negative restrictions, x greater than equal to 0, y greater than equal to 0, is called linear constraints. Optimization problem. A problem as maximize or minimize a linear function of two variables, say x and y, subject to certain constraints as determined by a set of linear inequalities. Before going to that problem, you have to some idea about the node. The term linear implies that all the mathematical relations used in the problem are linear relations. The term programming means the method of determining a plan of action or a particular program. That means for mathematical way, that is called mathematical formulation of the problem. Maximize z equals to c1x1 plus c2x2 plus dot dot plus cn xn. And subject to the constraints means a11x1 plus a12x2 plus a1n xn less than equals to equal greater than equals to b1, maybe less than equal, maybe equal, maybe greater than equal. The question is given, must be a11, a12, a1n are constants. Similar way, a21x1 plus a22x2 plus a2n xn less than equals to equal greater than equals to b2, and so on. am1x1 plus am2x2 plus a dot dot amn xn less than equals to equal greater than equals to bm. And non-negative restrictions are x1, x2, s3 dot dot xn greater than equals to 0. That means that there are three conditions. The first one is the maximize and minimize, and the second one is the subject to the constant, and third one is the non-negative restrictions. And x1, x2 are decision variables. It can be written as in matrix form. Maximize z equals to cx, subject to the constant s dot t, x less than equals to equal greater than equals to b, and x greater than equals to 0, where c equals to c1, c2 up to cn. That means the 1 by n matrix, that is a cost vector or cost coefficient matrix or row matrix, and that is similar way xy is equal to x1 x2 up to xn. It can be written as this n by 1, that is a column matrix, and b equals to b1, b2 up to bm, m by 1, and a equals to a11, a1 to a1n, and so on, am1, am2, mn, m by n matrix. And it can be formed in this way, a, x, b, and c. So that problem, how formulation of the problem can be solved by graphical way. We have to discuss about the first one, that is the terminologies. They are solution of a LPP. What is solution of a LPP? A sort of set of values of variables x1, x2 up to xn satisfying the constraints of a LPP. What is the feasible solution of LPP? A set of values of variables x1, x2 up to xn satisfying the constraints of LPP and non-negative restrictions of LPP. And those points xi and yi within and on the boundary of the feasible region represent feasible solutions of the LPP. And what is feasible region? The common region determine all the constraints including non-negative restrictions is called the feasible region or solution region for this problem. Otherwise, it is called infeasible region, feasible solution. Next one is feasible choice. Each point in the feasible region is called feasible choice. Infeasible solution, any point outside the feasible region. Optimal solution of LPP. A feasible solution of a LPP is said to be optimal or optimum if it is optimizes the objective function z of the problem. Graphical solution of a LPP. The solution of a LPP obtained by graphical method, that is drawing the graphs corresponding to the constants and non-negative restrictions. What is unbounded solution? If the value of the objective function can be increased or decreased indefinitely, then such solutions are called unbounded solutions. Discuss in example way, then easy for the students. Example 1. Solve graphical. 5x plus y less than equals to 100 and s plus y less than equal to 60. That means the x and y are two variables and this is a linear inequation and x greater than equals to y greater than equals to restrictions are there, and that means in quadrant 1 is given. And that means how can we solve graphically? There's a very easy way. We have to first step way we have to find out the solution. First one, we have to take step 1, 5s plus y equals to 100. Whatever may be the less than equals to or greater than equals to be given, but you have to take it equals to. And then you have to form in intercept form. And x by 20 plus y by 100 equals to 1. That is x intercept is equal to 20 and y intercept equals to 100. Suppose this is equals to line L1. Similarly, another one is given s plus y equals to 60. So automatically the x intercept is 60 and y's intercept is equal to 60. And the third point already given x greater than equals to 0, y greater than equals to 0. So three conditions. So automatically you have to step 2 and you have to draw the graph. Clearly you have to see it. And first one is line L1 and a point is here. A point is means x intercept, that is x intercept equals to 20, 0. And similar way another one this 0, 100. So draw the line L1. Similar way L2, x intercept is equal to 60, that means 60, 0. And another one y intercept is 60, 0, 60. Draw the line L2 and intersect it. And the two lines are given, that means one point is here. And we have to find out the solution B, that is 10, 50. That is in very simple 9th and 10th class. You know how can we solve it. X is equal to 10 and y is equal to 50. And the required point B equals to 10, 50. And step 4, we have to test it at origin, 0, 0. From 1 given already 5x plus y the left side, we have to take a choice it 0 plus 0 equals to 0, 0 less than equal to, just that means you have to satisfy it. That means satisfied means 5 by 0 is less than equals to 100. Satisfied means and go towards origin and exactly put again from 2x plus y left side to take it 0 and the less than equal to 60. Already the given less than equal to, and that means 0 less than equals to 60. That means the put again towards the line 2 line is exactly towards the origin. And therefore the common point is there. This is the common point and this is the common point and this is the region, the common point. But we go not towards quadrant 2 and quadrant 3 and quadrant 4, only the quadrant 1, because this is the quadrant 1 already discussed, the given x and y in quadrant 1. And therefore this is the only this, you know that this is the region. This is the region and that is called as O, A, B, C is the region. Then so from 6 and 7 draw the region towards origin 0, 0 within Q1. Therefore, OABC is the feasible region. Despite all the constants. So there are infinitely many points including origin 0, 0. So 0, 0, 0, 0 is the, again 0, 0. 0, 0 is the feasible solution. Also the A is the solution, B is the solution, and C is the solution, and the interior points also are the solution. So infinite many solutions in that area, that feasible region. Also this is the feasible regions is called the solutions of that inequalities, and that equation very easy equation, and you have to solve by graphical. So that the whole region are called the solutions, and including O point, A point, B point, and C point, and including the interior points. Very easy. And exactly another example you have to see it, that then already so solve LPP by graphically. Maximize Z 250x plus 75y, and same question already taken, because of you have to know about that, and that is because linear inequality is here. Also only add it, maximize Z is equal to 250x plus 75y. Then that means to solve graphically, but it can be LPP problem, because LPP problem, and the first point and second point that is maximize or optimize objective function and subject to the constant and non-negative restriction. So total the three parts, and that is called LPP problem. So therefore exactly from example 1 we have to do the same process, step 1 to step 5, and next go to only for step 6. So the corresponding value of Z after putting the vertex points or boundary points at 0, 0, at 0, 0 Z is equal to 0, at A Z equals to 5000, at B Z equals 6250, at C Z is equal to 4500. That means the maximum value at B. Maximum value at B Z is equal to 6250. So therefore maximum value of Z is equal to 6250 at point B 10, 50. We have to write it in this way. Maximum Z is equal to 6250 at B point 10, 50. Also you have to write maximum Z is equal to 6250 at X is equal to 10 and Y is equal to 50. Also you have to write the solution of LPP is X is equal to 10 and Y is equal to 50, and maximize Z is equal to 6250. And mathematical way you have to write Z max equals 6250 at X is equal to 10 and Y is equal to 50 are the required solution. Solutions. Again, example 3, solve. Only inequalities are given. Only inequalities. 5s plus y less than equals to 100, s plus y less than equals to 2. How can you solve it? Simple way. And we have to do the 4 steps. They are step 1, step 2, step 3, step 4. We have to do this. And after we draw the common region is this. Because the at 0, 0, 0, 0, towards the 0, 0, you have to draw the figures and draw this arrow line. Then that means the whole arrow sides are called the shaded region, and that shaded region is called the solution of the inequality, including origin 0, 0, because the origin is 0, 0 here. So 0, 0 is here, A is here, B is here, and C is here. There are 4 points including, and all these. These are the solutions. Z is equal to minus 50x plus 20y, subject to the constant 2x minus y greater than equals to minus 5, 3x plus y greater than equals to 3, 2x minus 3y less than equals to 12, and x greater than equals to y greater than 0. Already done these questions in the already said to your WhatsApp group and a link in YouTube. Entire notes given to you, and the entire notes and linked in your YouTube. And example 5 for homework, exactly another examples you have to take it and do it. The problem very easy problem. You have to do this. Lastly, general features of LPP. The feasible region is always a convex region. The maximize or minimize solution of the objective function occurs at the vertex or corner of the feasible region. If 2 corner points produce the same maximum or minimum values of the objective function Z, if the 2 points produce the same value, then every point on the segment joining these points, the 2 points are there and they're joining it, and these are the total all these points segment joining these points also give the same maximum or minimum value, and that means this is the maximum value and this is the maximum value, and the 2 points you have to join it. That is a line segment. That the total this any point you have to take it that the 2 points, then that is called the maximize and minimize value. The different types of LPP you have to, the higher class you know, the manufacturing problem, diet problem, transportation problem, and etc. And thank you very much. Best of luck for the students. Thank you very much. Lastly, we know about the convex region figures and convex. They are the convex figures, and they are not convex figure, because any 2 points are taken and draw the line segment, and that line segment is a subset of D1, and any 2 points draw it and the line segment is subset of D2. But here any point to take it PQ does not lie in that figure. And so these are the convex figures, and this is the not convex figures. And another one most important is, these are the very important examples and the figures. What are you have to do it? The polygons are not convex polygons. Why not convex polygons? Why not convex polygons? Because of any 2 point is given, just join it. There is no convex polygon, because no convex polygon, but it is a convex polygon. This is a very important chapter for that is linear programming problem. We have to know about the nodes first, then we have to do the exercise and examples from Elements of Mathematics, that is a government book, and for higher examples and different nodes in the R.D. Sharma book. Very interesting chapter, is the most important for the exam, and one long questions must be given by the CHSC board exam. That's why I hope you have to do that, the problem, very easy problem. That's why lastly we have to say the best of luck for the students for the CHSC exam. Thank you very much.